A little progress each day adds up to big results. Hi everyone. In this video we'll go through additional problems related to types of relations. Basically, the previous video we covered different types of relations. Here in this video we'll go through additional problems. You can refer relations and functions playlist for videos specific to this chapter or class 12 mathematics playlist which has all the videos specific to mathematics. So we'll take this problem. Show that the relation R in the set of real numbers defined as a less than or equal to b square is neither reflexive nor symmetric nor transitive. So we will have to show that it's none of these, right? So we will first write the set. What is a set here? Its set is R. Set is R. R means real numbers, right? Whenever they say set R, it means real numbers. And what are real numbers? Real numbers are all numbers, positive numbers, negative numbers, integers, fractions, decimals. All of this come under real numbers. So just for example, say R, that is set of real numbers. This is set of real numbers. So basically it will be positive numbers, right? Positive, negative numbers, or it could be fraction, half, 1 by 4, 1 by 8, again plus or minus, right? Decimals, right? All such numbers are real numbers. So now what is the relation given here? Relation is if you have an ordered pair where first element is A and second element is B, then A should be less than or equal to B square, right? This is how the relation should be. Now for example, if I take A is equal to 1 and B is equal to 2, then the ordered pair would be 1 comma B square, that is 2 square, which is going to be 1 comma 4. Let's figure out if this relation is reflexive. Now what is the condition for reflexive? For every element A that belongs to R, A comma A should belong to R. That is, the first element and the second element both should be same, which means 1 comma 1, I should get 2 comma 2, 3 comma 3 for all real numbers, or half comma half, or 1/4 comma 1/4, right? Or 0.5 comma 0.5, minus 1 comma minus 1. So basically you take any real number, the first element and second element has to be same. That's one condition, right? And second condition is it has to satisfy this relation also. What is the relation? The first element should be less than or equal to the square of the second element. Now, for example, if I take for reflexive, both first and second element should be same. Say I take A as half. Now what should the second element be? Second element also should be half for reflexive, because I'm going to take A comma A, right? And A comma A should belong to R. Now what is the first element? First element is half, okay? And second element should be square of the first element. Second element should be square of the first element. That is the relation given here. Now we have taken second element also as A, because for reflexive, first and second element you should take same element. So now this should be A square. A square is 1 by 2 the whole square, which is nothing but half comma 1 by 4. You used both first element and second element as the same element, which is one condition of reflexive. Now you notice this half. What is the condition? The first element should be less than or equal to second element, square of the second element. Now half is not less than, right? Half is not less than 1/4. What is half? Half is 0.5. What is 1/4? It is 0.25. Is half less than 0.25? No, right? 0.5 or half is greater than 1/4. Half is greater than 1/4. Therefore, this does not satisfy the relation at all. The relation that is given, first element should be less than the square of the second element, does not get satisfied. Half is not less than 1 by 4. That's why this does not belong to R, right? So I can say, how do I write that it's not reflexive? I'll say R is not reflexive as A less than or equal to A square is not true for all A that belongs to R. So for all elements which belong to real numbers, right, A less than A square is not true. Now we will check if it is symmetric, right? So for symmetric, what is the condition? For every AB that belongs to R, it implies that BA should belong to R. So the reverse combination should exist. So now let's take an example. Let's take A is equal to 2 and B is equal to 6. Right? Let's take this example. Now, for symmetric, what is the relation? A should be less than or equal to B square. So, now I take A as 2, B as 6. So, what will be the ordered pair? 2, 6 square. 6 square, which is 2, 36. This is fine. This satisfies the condition that A less than or equal to B square. Now, I'll reverse this. For symmetric, I should reverse, right? So, I'll take A is equal to 6 and B as 2. I'm reversing this, right? So, what will happen? It will be 6, B square. B square is 2 square, which is 6, 4. Now, you check if it satisfies the relation. What is the relation? A less than or equal to B square. Now, that means 6 less than or equal to B square, which is 4. Is 6 less than or equal to 4? No, right? So, we say it is not symmetric. It's not symmetric because for every AB that belongs to R, BA does not belong to R. Or I can say R is not symmetric because A less than or equal to B square does not imply or does not mean that B is less than or equal to A square. Now we'll check if it is transitive. Now what is the condition for transitive? A, B. If AB belongs to R and BC belongs to R, this should imply that A, C should belong to R. That is, this first element and this fourth element should belong to R. Now we should take an example to disprove this. See, in all of these cases, they've asked to prove that it is not reflexive, not symmetric, not transitive. So you have to disprove, right? So for that, you'll always have to take a example where you can prove that it is not transitive, right? We'll have to take a case where we say AC does not belong to R, right? That is the first element and the fourth element should not satisfy this condition. What is the condition? B less than or equal to A square. That means here first and fourth is A. That means A less than or equal to C square. This should not be true. This should be false. It should not be true, right? Basically, A should not be less than or equal to C square. So we'll have to take the numbers in that way. So which means A should be greater than C square. A should be greater than C square. So choose a number in such a way that A is big and C is small, right? So that is one of the clues. Let's say A is equal to 4 and we'll take a negative number, say B as -2 and C as 1. So we are going to take smallest number for C because we want C to be smaller and A to be greater. So we'll take a bigger number for A and a smaller number for C, and B will take a negative number, right? We'll take a negative number because if you take any number, positive number, will not be able to validate. So we'll take a negative number. So first combination is A, B, right? Which is nothing but 4, -2. So it should be 4, B square, right? The second element should be B square. So it is -2 the whole square, right? Which is going to be 4 and 4, right? Now 4 is less than or equal to. It's equal to. It satisfies, right? It satisfies. So this is fine. Now second one will say B, C, right? B, C, we'll take it as B is -2 and C is 1, but we have to put 1 square because second element should be square of the element. So minus 2 and 1 square, which is going to be minus 2 and 1. Now, is minus 2 less than 1? Yes, this is true. Now, since both of these are true, we'll have to figure out the third combination, which is A comma C. Right? Now, what is A comma C? What is A here? 4. And what is C? C is the second element. So, it should be square of the second element. What is C here? 1. What is square of 1 square? 1 only. So, it's going to be 4 comma 1. Now, what is the relation it has to satisfy? A less than or equal to B square. Right? So, you have 4. Is 4 less than or equal to 1? No. Therefore, this is not transitive. Right? So, we'll say R is not transitive as A less than or equal to B square and B less than or equal to C square does not imply that A is less than or equal to C square. Example we've already given. Now we'll go to the next problem. Check whether the relation is defined in set 1, 2, 3, 4, 5, 6 as R, where second element B is 1 greater than A, that is A plus 1, right? B is A plus 1. We'll have to check if this relation is reflexive, symmetric and transitive. First, we should write set. What is the set given? Set given is 1, 2, 3, 4, 5, 6. This is a set. And what is the relation? A comma B is the ordered pair. B should be A plus 1. Right? Now, let's form this relation. Right? It becomes easier when you have the set. So, if A is 1, then B is A plus 1. Right? So, it will be 1 plus 1, which is 2. If A is 2, I'm taking every element here. If A is 2, then B is 2 plus 1. And if A is 3, B is 3 plus 1. If A is 4, then B is 4 plus 1. And if A is 5, B is 5 plus 1. And if A is 6, B is 6 plus 1. Now let's stop here, because 6 and 6 plus 1, it's going to be 6 and 7. Is 7 belonging to the set? No. So we'll have to stop it here. So R is going to be 1 comma 2, 2 comma 3, 3 comma 4 and 4 comma 5 and 5 comma 6. So this is going to be the relation. Now we'll go figure out if it's reflexive. Right? Now what is the condition? A comma A should belong to R for every element A that belongs to R. Right? Now, do I have 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4? No, I don't have that ordered pair at all. Right? So basically, and one more way is, your second element is 1 greater than first element. So it's never possible that both the elements will be same. Right? If I take A as 1, B will become 2. If I take A as 5, B is going to become 6. Right? Every time B is going to be more than A. So there is no case where you will have both the elements as same. Right? So we'll say R is not reflexive. R is not reflexive as A comma A does not belong to R for all elements A belonging to R. Now let's check if it is symmetric. What is the condition for symmetric? A comma B belongs to R should imply that B comma A should also belong to R. B is nothing but A plus 1. Right? B is nothing but A plus 1. Right? So if I take A as 1 and B will be 2. So 1 comma 2 belongs to R. Now I'll reverse this. So if I take 1 comma 2 belongs to R, for symmetric 2 comma 1 should also belong to R. But here if you see in this relation, do we have 2 comma 1? We don't have 2 comma 1. Right? 2 comma 1 does not belong to R. So we can say for every A comma B that belongs to R does not imply that B comma A belongs to R. Or I can say relation is not symmetric because A comma B belongs to R but B comma A does not belong to R. Now we'll check out if it's transitive. Now what is the condition? A comma B belongs to R and B comma C belongs to R. This should imply that A comma C belongs to R. Now let's take this case 1 comma 2 and 2 comma 3, right? If you notice, you can call this as B, right? And this is A and this is C. 1 comma 2 and 2 comma 3 belongs to R, which means that A comma C should belong to R, which is 1 comma 3, right? 1 comma 3. Do we have 1 comma 3 in this relation? No. So we can say it's not transitive. So it's not transitive because A comma B belongs to R, B comma C belongs to R, but A comma C does not belong to R. And you can take this as an example. Example, you can write example 1 comma 2 belongs to R, 2 comma 3 belongs to R, but 1 comma 3 does not belong to R. Does not belong to R. Let's go to the next example. Show that relation R in R means the actual set is real numbers and the relation is given as R1. A should be less than or equal to B, right? The first element should be less than or equal to second element. You will have to show that it is reflexive and transitive, but it is not symmetric. Now we will show that it is reflexive first, right? We'll have to prove that it is reflexive. Now in R, that means the set is real numbers. So you have all positive numbers, negative numbers, decimals, fractions, everything. The relation is defined by first element should be less than or equal to second element. So for example, right, 1 comma 2, first element is less than second element. It can be also equal to, right? It can also be equal to. So I can take 1 comma 1, 2 comma 2, 3 comma 3, it can be equal, and then 2 less than 3, 3 less than 4. So there are infinite combinations. Now for reflexive, what is the condition? A comma A should belong to R, right? A comma A should belong to R for all A that belongs to R. Now if you take every real number here, right, you can have the same first element and second element. You can have it, and also it can satisfy this condition. Example 1 comma 1. You have 1 comma 1 here. You have 2 comma 2. You can have 3 comma 3. You can have half comma half, right? You can have half comma half, 0.5 comma 0.5. So you can have these pairs here, right? Since we can have first element and second element as same, since we have these pairs for every real number, we can say it is reflexive. So you can say as A is less than or equal to A, right? It's equal to, right? Whether I take 1 or 2 or 10 or minus 1, minus 2, minus 3, or I take decimal, that element is going to be equal to the second element. A less than or equal to A is true. Therefore, it's reflexive. Now, we'll check if it's transitive, right? We'll check if it's transitive. Now, for transitive, it should be A comma B belongs to R, B comma C belongs to R, A comma C should belong to R, right? If these two are true, then it should imply that A comma C should belong to R. Now we'll take this in this example itself. Say for example, I take 1 comma 2, right? I take this pair and I take 2 comma 3. I should get the second element same, right? Second element should be same, right? So 2 and 2. So I'll take this pair 1 comma 2 and 2 comma 3. What does this indicate? For transitive, there should be 1 comma 3. There should be 1 comma 3. If I have 1 comma 2, and 2 comma 3, this implies that 1 comma 3 should belong to R, right? That is, this element and this element should belong to R. So if you see 1 comma 3 belongs to R, right? Because if you go by this condition, right, A less than or equal to B, if I take A as 1 and B as 3, the condition is satisfied. A is less than or equal to B. 1 is less than 3. The condition is satisfied. So therefore, you take any combination, right? any combination, you will see that it is transitive because it's less than, right? If you see that first pair satisfies the condition and second pair, which is B comma C, satisfies this condition, then the third pair also will satisfy this condition. Therefore, it is transitive. So we'll have to simply say that relation is transitive because for every, you can write that, for every AB belonging to R and BC belonging to R, it implies that AC belongs to R, right? Or you can also write it as R is transitive, R1, right? That's what they gave in the question. R1 is transitive as A less than or equal to B and B less than or equal to C implies that A is less than or equal to C, right? You can write this and say R is transitive. Now we'll have to verify that it is not symmetric. We'll have to prove that it is not symmetric. Now, what is the condition for symmetric? If A comma B belongs to R, this should imply that B comma A should also belong to R. Now, let's take simple example 1 comma 2. Here 1 is less than or equal to 2. That's the condition, right? A should be less than or equal to B. That's the condition for relation. A less than or equal to B. So here in this case 1 is less than or equal to 2. Now I'll reverse this, right? So I'll make A as 2 and B as 1, right? BA combination. So is 2 less than or equal to 1? No, right? No. Therefore, it's not symmetric. So you'll have to say R1 is not symmetric as A less than or equal to B does not imply that B is less than or equal to A, right? Example 1 comma 2 belongs to R does not imply 2 comma 1 belongs to R. Or I can write 1 is less than or equal to 2 does not imply 2 is less than or equal to 1, right? So this way, either of this way, you can tell that it is not symmetric. Now we'll go to the next example. Check whether the relation R. This means it is real numbers. And relation is R given by A less than or equal to B cube. A should be less than or equal to B cube. And you will have to check if it's reflexive, symmetric or transitive. Now we'll first write the relation. Relation is A comma B, where A less than or equal to B cube. Now let's take one example here. Let's take A is equal to half, right? It's a real number. So normally we can take fraction when you can, best way is take a fraction. So you can really prove or disprove if it's reflexive or not. So fraction is always a good case, right? So I'll take A as half, right? So for reflexive, first element and second element should be same, right? So A comma A should belong to R. This is the reflexive condition. So if I take A as half, so A as half, second element should be B cube, half the whole cube, right? And A should be less than or equal to B cube. That is, the first element half should be less than or equal to cube of second element. What is 1 by 2 the whole cube? It's 1 by 8, right? So is half less than or equal to 1 by 8? No. Half is not less than 1 by 8. Half is greater than 1 by 8. So we should write it as R is not reflexive. R is not reflexive as A less than or equal to A cube is not true for every element that belongs to R, right? Example is half. If I take half, is half less than or equal to half cube? No. Therefore, R is not reflexive. Now we'll figure out if it is symmetric. Now what is the condition for symmetric? A comma B belongs to R implies that B comma A should belong to R. Now in this case, A less than or equal to B cube. This is the relation. A less than or equal to B cube is the relation, right? This is the condition. So we'll have to check if A less than or equal to B cube. This should imply that B should be less than or equal to A cube. I'm just reversing A and B here, right? Now let's take an example and verify. Let's take A as 1 and B as 2. Simple example, right? Now if I take A as 1 and B as 2, so this combination would be 1 and B cube, that is 2 cube, This is going to be 1 and 8, right? This satisfies the condition because 1 is less than or equal to 8. This is fine. Now we'll reverse this, right? We'll take A as 2 and B as 1. So if I take A as 2, it will be 2 comma, it should be B cube, isn't it? So it will be 1 cube. So which is going to be 2 comma 1. Now is 2 less than or equal to 1? No. No. So B comma A condition is not getting satisfied. So we can write R is not symmetric because A less than or equal to B cube does not imply that B is less than or equal to A cube. Example, 1 less than or equal to, we'll take the same example. 1 less than or equal to 2 cube does not mean that 2 is less than 1 cube, right? 2 is not less than 1 cube. Therefore, R is not symmetric. So you can take an example and put it here. So we figured out that R is not reflexive, R is not symmetric. Third thing is we'll check if R is transitive. Now what is the combination for transitive? AB belongs to R, BC belongs to R, should imply that A comma C belongs to R. Now first we'll have to take a case to prove that it is not transitive. So we'll have to take numbers in such a way that it does not satisfy this condition. What is the condition? A less than or equal to B cube. Now we'll have to find out some example where this condition is false or not true, right? Whatever number I take for A and C, it should not satisfy this condition. Basically, A less than or equal to C cube should be false, right? A should not be less than or equal to C cube. That's how we should take the numbers. So what we will do, A should not be less than. That means A should be greater than C. A should be greater than C. So take a big number for A. Take a big number. Let's take A as 10 and B as 5 and C as, we'll have to take a small number. So we'll take 2. So now AB combination, right? Which means we'll take A is 10, first element. What is second element? It should be cube of, second element should be cube, right? Cube of second element. So 5 cube, right? This is nothing but 10, 125, right? So does it satisfy the condition? A should be less than or equal to B cube. Yes, 10 is less than 125, true. Then we'll take BC combination, right? So BC will take 5 and 2. 5 and second element should be cube, right? So 2 cube. So this is going to be 5 comma 8. Now is 5 less than 8? Yes, true. Now what is the third combination? AC combination. AC belongs to R. Now A is 10. C should be cube of that element. Cube of 2. 2 cube. Which is 10 comma 8. Now, is 10 less than 8? No, false. Right? So, we found out a case where A is less than or equal to C cube is false. This condition is false. So, we'll say it is not transitive. We can say R is not transitive as A less than or equal to B cube and B less than or equal to C cube does not imply that A is less than or equal to C cube. Example, we'll take the same example, 10, 5, 2. So, 10 less than or equal to 5 cube, B was 5 less than or equal to C was 2. 2 cube does not imply, what was A? 10. 10 is less than or equal to C. What is C? C is 2. 2 cube. Right? 10 is less than or equal to 125. 5 is less than or equal to 8. But 10 is not less than or equal to 8, right? You will get 10 less than or equal to 8 here. So this is not true. Not true. So R is not transitive. Now let's take this problem. Show that the relation R in the set 1, 2, 3, set is given as 1, 2, 3, given by relation set is given here. Two ordered pairs are there, 1, 2 and 2, 1. you will have to show that it is symmetric, neither reflexive nor transitive. So we'll have to prove that it is symmetric, right? We'll have to prove that it is symmetric. What is the condition for symmetric? A comma B belongs to R implies that B comma A belongs to R. So here if you see, you have 1 comma 2. Take the first ordered pair, 1 comma 2, it belongs to R. Does it imply that 2 comma 1 belongs to R? If 1 comma 2 belongs to R, the reverse combination 2 comma 1 should belong to R. So 2 comma 1 is here. Therefore it is symmetric, right? It is symmetric. You have only 2 ordered pairs here. We checked both. Now we'll have to check if it's reflexive, right? We'll have to prove that it is not reflexive. It is simple, right? For reflexive, you should have A comma A belongs to R. Now the set is 1, 2, 3, right? Set is given here, 1, 2, 3. So for every element of the set, you should have A comma A. That is, you should have first element and second element as same. That means you should have 1 comma 1, 2 comma 2, 3 comma 3. Only if all these 3 pairs are there, all 3 pairs are there, then you can call it reflexive. But you don't see those pairs here. You don't see 1 comma 1, 2 comma 2, 3 comma 3. Therefore, it is not reflexive. So we can say R is not reflexive as 1 comma 1 does not belong to R. Simple, right? Now we'll go ahead with transitive condition, right? What does it indicate? A comma B belongs to R. B comma C belongs to R. A comma C should belong to R. Now we have only 2 ordered pairs. So you have 1 comma 2 and 2 comma 1. So if you notice here, the second element is same, right? That means you can take it as A comma B and B comma C. Now this should imply that A comma C. Now what is A here? 1. 1. And what is C here? 1. Do we have 1 comma 1 in this set? No, we don't have 1 comma 1. So it's not transitive. So we'll have to tell that R is not, so we'll have to write it as R is not transitive. R is not transitive as 1 comma 2 belongs to R, 2 comma 1 also belongs to R, but 1 comma 1 does not belong to R, right? 1 comma 1 does not belong to R. So with this, we've come to the end of this particular topic. If you like this video, do press a like and share it. Thank you.